Hello, everyone, and we are super live. Very excited to be here. Data on Kubernetes live stream 130. I do apologize because it feels like we've been saying that in a couple of the last live streams we've been having. You can take it from me. This is the definitive number 130. We will not have anything else. There will be no more confusion about this number. That being said, we've got a lot of things going on right now at the moment. May is a very busy month. Our speaker will tell you about the stuff that he's going to be doing in May as well, because he's also very active. Just really quickly want to let everybody know, if you have not signed up for DoK Day, why not, first of all? But better yet, you can very easily do so with just a couple of clicks, right? And very importantly, too, we want you to get involved in a challenge that we've launched, right? You know that one of the core symbols of the Data on Kubernetes community is the horn that we use to announce meetups. And you may have noticed that for the promo for today's meetup, it was without a horn, right? The DoK horn has gone missing, and we need all of your help to find it, all right? We've given very clear instructions about what to do on Twitter. So if you go to the DoK Twitter, you'll see all the stuff that you need to know there. I will drop the link here so you can see exactly what's going on. As usual, we've got some pretty cool videos telling a story about exactly what's happened to the horn, the sort of aftermath. So I'm gonna drop that. I'm gonna drop the link in here right now so you can check that out in your own time. But get involved in helping us try to find it, all right? And also, like I said, if you haven't signed up for DoK Day, it's free. You just got to add it on to your KubeCon registration. It couldn't be easier. We've got over 30 talks and panels. And the gentleman who I'm with right now happens to be one of the people who will be giving a talk in KubeCon. His name is Robert Hodges. He is the CEO of Altinity. He is also a person who I'm very lucky to have met in person. And no spoilers, but we will be planning some kind of a DoK meetup together in July in San Francisco if you're around. That being said, Robert, welcome back. Very good to have you. How are you doing?
I'm doing great, Bart. Thank you. Thank you for the invite. Good
to have you. And so can you just tell us really quickly, what are you going to be speaking about in DoK Day?
This is terrible. I think I had a couple of topics. I believe I'm talking about replication on Kubernetes and moving data at speed. It's a really important topic. How do you move things around? I know I'll be taking 10 minutes on it. But it's turned out that what we have found through working with hundreds of users of data warehouses, Kubernetes is turning out to be the place to build data pipelines. It's because you can just, spin up Kubernetes. I'll talk about this in my talk.
Okay.
And then you can just drop in various pieces of the data pipeline and then have them easily connect up to each other through the wonders of DNS inside your Kubernetes cluster. So it's a very powerful, it's a very powerful model, and one that we're very interested in, and we'll be doing a number of talks about in the near future.
All right, sounds good. That being said, for today's talk, though, what are we going to be learning about?
We're going to be talking about portability and on Kubernetes and how it enables a new management model. Along the way, I will shamelessly describe what we're doing. So because that kind of led to an understanding of this model. But the real point of this talk is that Kubernetes opens up some very interesting new doors that allow people to manage data in a distributed, decentralized way. And that's what I'll be digging into.
All right, sounds good. That being said, you want to start sharing your screen? We can check out your presentation. Folks, as usual, get your questions in the chat, all right? Robert is very, very knowledgeable and won't mind me interrupting him. I won't do it mid-sentence, but this is a solid title, Leaning on Kubernetes Portability to Manage Databases Anywhere. Love this, leveraging the goodness of Kubernetes, getting on the inside, making it happen. Robert, take it away.
Great. Thanks again, Bart. All right. So you can see the topic. I don't need to read it again. In fact, I'm going to go ahead and just give me 1 second here, Bart. I'm going to kill my video just so that I doesn't consume bandwidth. All right. Off it goes. We're disappearing from the screen. So I'll be talking about this Kubernetes portability model and how we are using it to open up what is now becoming apparent is a new management model. Just a little bit about me. I'm a database geek. So I've been working on databases for 30 plus years. I put that down because if I said what it really is, which is now about 39 years, it makes me sound old. But I've been doing it for a long time. I've worked with about 20 different types of databases, worked with a number of startups. The last one I worked for, we sold to VMware. And my day job is I'm a CEO of Altinity. So I have backing me up. This is really, I'm describing the experience. I'm really not describing my own experience, but the experience of our engineering team. So we are database geeks. Sort of across the board, we have centuries of experience with databases and applications, particularly strong in analytic databases. And that's good because what we do as a business is we support ClickHouse, and we have a cloud platform for it called Altinity.cloud. And we're also author of the Kubernetes operator for ClickHouse. And that's one of the ways that we've gained the experience that enabled us to give this talk. So that's us. Let me just dive in and tell you where this story started. So it didn't start well. And this is sort of the, this part is personal. Back in 2018, I was actually applying for this job as CEO. At the time, I was working for VMware. And so I went and had dinner with a couple of the guys on the board, Peter Zaitsev and Vadim Tachenko. If you're involved in MySQL or Postgres at any level in the community, you know who they are. They're world famous. Wrote the book on MySQL performance. Anyway, we're sitting at this table that's highlighted here, and talking about what they wanted to do with this little company that they were had helped start. And at some point, Peter said, well, we also have an idea that there's a real opportunity here to run databases on Kubernetes. And I thought this was a terrible idea. So, and it's a common reaction with database people. And anyway, we ended up having almost like a knockdown argument about whether it was really possible to run large databases or databases of any complexity on Kubernetes. And this was not quite as dumb as it sounds, because I was actually working on Kubernetes at VMware, and we had a lot of problems with it. At that point, this was back in 2018, storage was not easy to manage. A lot of it was local. So it was a difficult environment to work in. And in fact, a few weeks before this conversation, I had managed to destroy the Helm installation on a production system by issuing a command that then affected the services running in the kube system namespace, which I could not see. So this was my first taste of the complexities of Kubernetes security, and it was not impressive. I wiped out Helm, got calls from people, and it was just an overall bad experience. So coming in, I had some reasons to be doubtful. We'd never really settled the argument there. I ended up getting the job, not because I was a Kubernetes expert, because I offered to work for free for 6 months. And that was sort of, allowed them to overlook some of my other faults. But it was the beginning of a journey with, developing on Kubernetes and building building the infrastructure that would allow us to manage data there. And in fact, it turned out to be a really great experience. So there were 3 parts to it. The first was just getting Kubernetes to be an effective platform to host ClickHouse. And one of the things I should also say was in this conversation that I had with the board members, I didn't know about operators. And so the first thing that I learned about was how operators can help manage databases. And ClickHouse is a great example of an application on Kubernetes that needs an operator. So if you're not familiar with them, you probably are if you're listening to this. But just to give some context, ClickHouse, like many databases, is a large distributed application. So it allows you to shard data. It will replicate data within shards. And then it also connects to Zookeeper, which is necessary or there's a new service called ClickHouse Keeper. But the point is you have a separate service that helps all the replicas keep track of what they need to share, or the information that they need to share. So it's complicated. And you can see the basic topology here spread across availability zones, replication within the shards, and then of course communications between shards when we're actually doing queries and need to go fetch data from them. So if you set this up on Kubernetes, it is kind of a nightmare if you're just doing it from scratch. And this picture just gives you a partial picture, sort of a partial illustration of the complexity that you're facing. It's difficult to manage. And in fact, it's one of the things that sort of troubled me about Kubernetes and Helm, is that Helm is just not up to doing this level of management. Because not only do you have to lay these things out, and there's a complex infrastructure, but you have to deal with changes. So for example, upgrades, where you have to very carefully mutate the state of the of what's going on in Kubernetes. You have to keep, for example, doing round, sort of rolling upgrades, things like that. And Kubernetes has ways of dealing with databases, for example, stateful sets. They are actually not up to the job of dealing with something as complicated as a data warehouse, where things may run in different versions, where the pods may have different definitions. So as a result, this is a really complicated problem. Well, it turns out that operators do solve this very well, and there's a couple of things about them that are great. One is that they can reduce the complexity, like what you saw on that previous screen would be, stateful set definitions, PVCs, PVs, well, maybe not PVs, but configuration maps and all these other things. These are things that you have to do individually. With an operator, you can reduce this to a single file that's relatively simple. And you can go ahead and just apply that. And then what will happen is that that ClickHouse resource definition is defined as a resource type in ClickHouse, or excuse me, in Kubernetes. When it shows up on Kubernetes, it will be intercepted and then handed off to the operator, which runs as a container and then can decide what to do with it. And what it does is it looks at what you have, and then it inspects what's going, the resources that are already allocated out in Kubernetes, and it will basically make an adjustment to reality so that the resource definitions in your CRD then impose the reality that Kubernetes is actually implemented. That's a long way of saying that you get a database set up, and not only is it set up, but it's what you might call a best practice deployment. So anything that we think that makes this work better, the operator will just take care of configuring things properly. This is a huge improvement over setting things up directly using deployments and other low-level resources. What I'd like to do is just give a quick example of these CRDs. I won't belabor it, but this runs to 3 pages, but given the complexity of the system, it's relatively simple. So for example, on the first page, we have things like, shards and replicas. And rather than having having to specify the topology in a complicated way, we just say, let there be 2 shards and let there be two replicas. We can tell where Zookeeper is. So give a notion of where our, distributed or sort of consensus is held. We can refer to templates for things like pods and volume claims. We'll show those in a minute. And in fact, we can expand this. The templates are very powerful. For instance, the pod template I'm using just tells, okay, what container do we want for ClickHouse? There's the image name. It's one of our own builds of ClickHouse. And then actually a very important set of properties, basically setting anti-affinity. So what this does is it enables us to force distribution of the pods across across nodes. Now, if you're a Kubernetes expert, of course, these types of things you can do yourself, but it's just better to have this simplified syntax. Same thing for storage. So we volume claim template. We can do some interesting things like set retain, so that if our cluster gets deleted by accident, our storage just doesn't vaporize. And then, of course, we ask how much storage we want. So this is not a totally simple document, but compared to the overall complexity of the resources that get allocated, it is very, very simple. And what's interesting about it is not only is it relatively simple, but it will also run anywhere. So, and that's where we see the first example of just how powerful this portability is. So I typically, when I'm testing stuff, I typically run it on Minikube. Minikube is great. It's wonderful for development. It runs brilliantly on Linux. So I can test this out and set up the cluster on Minikube. But then what I can do is once I'm satisfied with it, I can turn around and I can take the same resource definition and I can load it on a cluster in Amazon EKS, and it'll run there as well. It will also allocate it will also allocate a ClickHouse cluster for me. There, I can turn around and run it in Google Kubernetes Engine. In both cases, I get a cluster come up, and it basically does this. It has the same topology and the same properties as it had on Minikube. That is a very powerful feature, because what it means is that as a developer, I can test things out and I can quickly iterate through things. And when I'm done, I can then push it to big Kubernetes running in the cloud. So this is a very powerful feature. Now, there are some, like other portability solutions, like Java, for example, which was very popular for this in the day. Certain things are portable and certain things are not. So the things that tend to map very well are things like the cluster topology, like what are the pieces, like how many replicas, how many shards, configuration map values, pod definitions. Oops, looks like we want to, I think we don't want to reboot the computer. We'll make that go away. All the way down to storage definitions. What's kind of cool about that resource definition is that would allocate persistent storage using the default storage class, which every Kubernetes cluster has. And so I would simply get, I get a cluster come up with persistent storage, and it would just work. I can tweak it beyond that to be more specific about quality of service, but basically all these things are portable. Now, what's not portable? As you move across clusters, one of the things you quickly realize is services, which are basically the front door to your applications and enable connections to come in and then, for example, get load balanced across pods. They are not portable. Mapping to external network resources like Amazon Elastic Load Balancing. DNS and certificates. Well, Kubernetes doesn't know about that, and like particularly outside, but what's going on outside the cluster, and then topics like security in general. These are not covered. Sort of various ways that you can protect ports, so on and so forth. And I'd like to give a concrete example of this, because actually when we're setting up these clusters, excuse me, one of the things that is really most difficult to deal with is, what does your service definition look like? And so here's an example of annotations that we've just provided that will basically allocate different that have the appropriate annotations for different clouds where this service might happen to run. And as you can see, every one of these services, like Amazon, Azure, OpenStack, so on and so forth, they all have different annotation types. So these are not commensurate. And so, for example, if I run this on Amazon, I'm going to get an NLB, so our network load balancer is going to be my front door. Moreover, it's going to be it should use an internal VPC address. It shouldn't appear publicly on the internet. How do I know? Well, the fact is that I actually have to try it and find out, because there's enough differences between different cloud implementations that without trying it, I don't really know if these properties are going to work. So this is a very important place where Kubernetes is not portable, and in fact, we need to do extra work to be able to move between different environments. But generally speaking, the CRD is, other than the networking and the things I mentioned, it works really well across a wide variety of environments. So that portability was really important to us, because it meant that this Kubernetes operator that we developed could now be a building block. And in fact, more than a building block, it could be the foundation of building a cloud service to run ClickHouse. We call this service Altinity.cloud, and what I'd like to do is just tell you a little bit about how it works. So the basic idea is pretty simple. As with almost all clouds, we have a central management plane, actually, which runs inside Kubernetes. So you can regard this as You have the Kubernetes control plane. That's of course your API. That's how we get stuff into it. But it runs a service called the Altinity Cloud Manager, and that's really our management plane. It knows about the different tenants that we have and where they're located. And the way that we manage tenants is in each case, tenants get what are called environments. They are places where they can bring up clusters. They run in particular regions of either Amazon or Google Cloud. And in each case, the environment is just a Kubernetes cluster, and which we spin up using GKE or EKS, depending on where we're running. And so you can then go ahead, and this has the operator inside it, as I'll show you shortly. And you have the ability to build new to build new clusters and to change them, upgrade them, so on and so forth. Moreover, we take care of arranging the external connectivity so that you can connect to Kafka. That's where you load events. You can connect to S3. That's where if you're going to read out of data lakes, you need to go get to S3. You can build your own applications. Golang is really popular to load events into these, and they can all talk to the to the data warehouse. Moreover, you can build, of course, end user applications, which then turn around and just issue queries on the data that's been loaded from these upstream data sources. And this is all controlled by your development team, who don't have to know any of the details about how this is done underneath. Instead, what they do is they just go through a panel that shows them their clusters and then enables them to do operations on them easily. So I'm going to give a quick example of this, if I can escape out of here, and just show you what Altinity.cloud looks like. So I want to go ahead and back up. This is an environment. It's in our staging environment, and it's where we put a number of our sort of test clusters or things that we're sort of data that we have internal that we're using internally. You can see that each of the clusters is a card. And one cool feature about this cloud, which I love, is that you can set a schedule on it so that if you don't use it for an hour or something like that, it just turns off, which is great because it means that we just free up the VMs you're using, and it costs you nothing to run. So we have a couple of active clusters in here. I'm going to go into one of them. This is one I'm using for a talk that's going to be at the next Databricks conference at the end of June. And basically, I'm using it to load a trillion row data set, or generate and load a trillion row data set that we can then run interesting queries on. So kinds of things that we can do when I'm just playing around with it. For example, I have a single node. It's M5 2x large. But one of the things I can do at any time is I can basically go ahead and let's go ahead and rescale this thing. So I'm running with 8 vCPUs. I can go ahead and set this up to something enormous. If I really want some horsepower, I'm going to go set this to M5 8x large. And if I go ahead and punch the button, that will right then and there go ahead and deallocate the old VM, respin a new one, reconnect it to the block storage there where my data lives, and bang, I'll have a new VM. I can also add shards. I can add replicas. I can change the storage size. This is just one example of the kinds of things that I can do with this. Other things that are useful in this type of environment, let's just go into exploration. This is where we can actually, we can actually look at the data. And so, for example, let's see what's going on in the schema here. No big secrets. These are files that I'm tables that I'm working with as part of the development for this paper. I can see how big they are. And I can also go ahead and look in more detail about important properties like column compression. This turns out in data warehouses to be incredibly important. So this shows me the level of compression that I get in different, in these different columns. So to make a long story short, this is really great if you want to work on ClickHouse, because it is a complicated application. You don't have to know even what we did to prepare the CRD. We took care of everything, gave you external connectivity. You can get to it, you can play around with it, and you can develop your applications very, very quickly. So far, so good. This is really similar to the cloud experience that we get practically everywhere else. So what I'm going to do is come back and show you how it works underneath and some of the portability issues that we ran into. So let me first go back, and I'm going to do a quick, actually, one thing I'm going to do is go ahead and stop this so we don't burn any more money than necessary. So this will now happily stop, and let's go back to the presentation. Okay, so what's going on under the covers? Well, as I mentioned, we actually have the, we have the Altinity.cloud. This is the centralized management plane that is running in Kubernetes. It's using a VPN to connect into the control plane API. And what we do once we spin up the cluster, which we do using Terraform, is we then inject a bunch of software into it. So for example, the Altinity operator that I described to you, we inject that. We also set up monitoring inside it using Prometheus and Grafana. When people go ahead and and choose the, go ahead and choose the, to start a cluster, we'll then spin up the cluster. We'll spin up Zookeeper to keep it company and track what needs to be replicated. And then there are other services that also get injected in so that this environment can actually properly function. One interesting thing that I should point out, and this is part of what the, sort of important to our business, but I think important to a lot of people that run data, is that within this Altinity.cloud, the runtime components that we inject in are all open source. So for example, ClickHouse is Apache licensed. So is Apache Zookeeper. Grafana, Prometheus is Apache licensed. Grafana has I think AGPL v3, but these are all open and can basically run anywhere. So you can pull down your own copies of these and run them yourself. This is something that will become important later. So this is 100% open source. What I'd like to talk about now is some of the portability, is just discuss a little bit about the portability issues we faced and one particular problem that we solved. So if you look at the overall portability of this service, it's pretty good. The containers, for example, are identical across Kubernetes clusters. This is a really wonderful feature of cloud native applications, that containers, because they encapsulate all the dependencies, they will run anywhere. So there's really, ClickHouse is distributed as a Docker image, and it will run pretty much anywhere that supports Docker. As a result of this, and the fact that we're using Kubernetes, so that most of the control logic is taken care of by the Kubernetes operator, we were actually able to port from Amazon, which is where we started, to GCP and get customers out on it in under 2 months. And if you're dealing with software, being able to port this quickly across clouds is a really, really big thing. And because this is the time from when we said, hey, we're going to do it, to the time we were able to load the first customer, it was only 2 months. So that's really fast. Now, there are still portability headaches, but they're not, because they're things that are not covered by Kubernetes. And they are really very similar to the things that we already knew were portability problems from the Altinity ClickHouse operator. And they include things like networking and ingress configuration. Obviously, now that we're running a service, ensuring that we're using cloud vendor resources efficiently. So, for example, network egress costs, which are kind of infamous on Amazon, and then security. These are all problems that you have to deal with. But what's kind of interesting is, to the extent that you have portability problems around things like networking, one of the ways that you can solve them is just push more services into Kubernetes itself. And I want to show a specific example of this that turned out to be really important to us. So when we first built the built these clusters and started running it as a service, we used the Amazon Elastic Load Balancing, specifically network load balancers. And as I showed just a few slides ago, you can actually set this up using the operator. But what happens and what actually gets deployed is when you create a cluster, you are going to end up having an NLB, so a network load balancer deployed for you. It will route or forward the traffic to your cluster service. So the service, the round robin service, that then gives you access to the pods that have individual nodes of your Kubernetes cluster. So this works, but only kind of. And there were a number of problems that we ran into. First of all, the NLB is not capable of load balancing across more than one service. It's basically tied to the service that created it. So here we have the NLB, it's pointing to the cluster service, but for example, we have pod services that would allow us to get into individual pods. We can't see them through the NLB. So that was a problem. Another thing was that the NLB does TLS termination. So we don't allow connections that are not encrypted, TLS encrypted. So they arrive here at the NLB, you get TLS termination at that point, and then the traffic gets forwarded over to the cluster service. At that point, you lose the originating IP address. So our ability to do whitelisting and other things like that was severely limited because of that. And then a final thing is that every time you spin up a cluster, you've got to allocate an NLB. That has two problems. One, it's expensive. The second thing is it's really slow. This is one of the slowest resource. In fact, when we allocate clusters, we use auto scaling. Well, actually, Carpenter to allocate nodes in the Kubernetes cluster. That's actually pretty quick. But the NLB could take 20 to 40 minutes in some cases to come up, which meant that you had this tremendously long period of time waiting for the NLB to show up. So that, and then of course you have to pay for each one individually. So this really was not suitable. It was a problem on Amazon. It was also meant that every time we went to another cluster, we would have similar issues, or another cloud type, we would have similar issues arranging the external connectivity. So we solved it. And what we did is if you see something you don't like inside Kubernetes, and you can get at it from inside Kubernetes, what you can do is write a service which solves the problem for you. And in our case, what we did was we wrote something called the Altinity Edge Proxy, which basically is the service that accepts the connections, the traffic forwarded from the NLB. And what that does is it means that we just have the NLB forward the traffic without opening it up straight into the edge proxy. And then within the edge proxy, we implement things like SNI routing. So now we can go ahead and actually have, if your server name indications, it gives us the ability to allow clients to specify which specific node inside the ClickHouse cluster they want to go to. So that's great. It gives us the ability to go to individual pods. That's important for operation. We do TCP/IP proxying so that when these arrive at the service, we actually know what the IP address is. And then we can do things like IP whitelisting in a global way. Best of all, there's just one NLB for the entire Kubernetes cluster. When we spin up new clusters, we just do a quick configuration change on the edge proxies, which are very lightweight and can accept configuration changes almost instantly. And now what we have is a very fast, very efficient, and very portable solution that gives us the gateway for the external network connectivity coming into our clusters. So this was an example of where the connectivity Kubernetes, the fact that you can run services inside it, gives us the ability to make Kubernetes more portable. So that then, of course, running a cloud service, this just means we can run that much more easily wherever Kubernetes runs. And there's been an important change in the Kubernetes ecosystem since we started working on this, and or certainly since over the last few years. And that is that every public cloud that's worthy of the name has a managed Kubernetes service. So this shows you the major ones. And they're so, for example, Google was the first out of the gate with GKE. They went production in 2015, all the way down to DigitalOcean, which has in 2019 introduced production Kubernetes cloud, or Kubernetes managed Kubernetes. So, with this portability, we can basically quickly set up in these different clouds, and that's a huge advantage of, if you're running a cloud service, because now we can be multi-cloud without too much difficulty. So at this point, the portability of the CRDs and the portability that you can get just because you're using within, like you're running within Kubernetes, and you can sort of encapsulate problems inside Kubernetes itself and then just distribute the software to solve them. That gives us a really great portability story. But at this point, we're still operating a cloud. What I'd like to talk about right now is how what we've seen so far actually enables an entirely new method of operation. So, and this really amounts to a new model for cloud, for data management. And I call this Cloud Experience Anywhere, but let me first dive in and do just sort of a quick review of server computing, because server computing has bounced around in a kind of interesting way. What you see below this line on this calendar are things like the IBM mainframe, which is one of the first places things I worked on when I got my first job, to Scott McNealy talking about sort of network connected Sun servers, all the way to of course the public clouds, Amazon, Google, Azure, and others. These have all sort of been advances that have promoted centralization. Obviously, the mainframe is single shared computer. Centralization, in the case of McNealy and the Sun's work, was what enabled the whole SaaS explosion beginning at the end of the 90s, because you could buy these servers, sort of increase them quickly, connect them over networks, and then of course the huge centralization we've seen in the public clouds. At the same time, above the line, you see things like the PDP-11, which first appeared in about 1970. And then after that, software like VMware or Kubernetes, these have been things which have tended to have enabled people to run in a decentralized fashion. So for example, VMware allowed corporations to build what amounted to private clouds. And VMware, of course, by sort of the 2010s, was dominant in enterprises. This was a huge advance and allowed enterprises to have, to scale computing, just buy a bunch of servers and then run a completely different, a bunch of applications on top of them without really caring about the boundaries of the servers themselves. So this is really important. And what's happened is, in the current iteration of the cloud, we see a tremendous amount of cloud native data management where the data is centralized on the cloud. So the products like Snowflake, so on and so forth, and these are very popular. The obvious reason is that SaaS services themselves are a great model for users, because they mean you can just go to a screen, ask for a database to spin up, and it just appears, and then you connect to it with your applications. You don't have to worry about how that was done. You don't have to worry about what happens when it needs to get upgraded. You don't have to worry about what happens when there's a bug. There are people behind the scenes who solve all those problems for you. So this model is enormously popular. And there's, in fact, if you talk to some people, for example, if you talk to Gartner, their view is that all data will move into the cloud. That's going to be where all the innovation in data management is going to happen. And so I guess the question you can ask is, is this inevitable? Is it that, are we seeing a pendulum swing permanently towards centralization of data? And I think it's kind of like this. Let's see if we can get this to run. There's a famous Miller beer commercial back in I think about 1997, which talked about this problem. Of course, they weren't talking about managing data. They were talking about managing beer. And just the fact that, hey, what we all want is to drink beer. It's time to drink beer from vats the size of Rhode Island. And this commercial was beautiful because it just celebrated what had happened to American beer making, and which had become enormously centralized, and everybody got their beer from a small number of brewers. Of course, what happened about that time and what they were trying to combat against was the whole movement of microbrews. And that was part of the reason this commercial was kind of a satire of that. But it's interesting if you think, like, is this what's going to happen also to data? And there's a lot of religious argument about that. Now, one of the things you can do is to cut through this is you can actually go ask users, do you want your data to be fully centralized? And what's kind of interesting is we have about 200 customers right now. And so we talk to them constantly. And in our latest customer survey, we got some kind of interesting results, which I want to share with you. So for example, 51% of the people that responded run ClickHouse on-prem. Well, that's kind of weird. Everything's moving to the cloud. Or if they're in the cloud, they're managing it themselves. They're not actually trying to put it into a cloud service. This is partly because they didn't exist, but actually at this time we have a cloud service and people are not using it. Moreover, another interesting thing was that just overall 25% of the respondents already run Kubernetes in their environments. And in fact, it turns out an awful lot of them were using of those 80%, where at least 80% are already using our Kubernetes operator and running it themselves. And in fact, as we look at people, talk to people who want to move to the cloud, the biggest reason why they don't come onto our cloud is that they want direct control of the data and the operating environment. And there's a bunch of reasons for this. I'll just give you a couple. Large corporations tend to have very strict data compliance requirements. So they just have to have control of the environment, and they have to, so that they can enforce security policies and have complete control over that, and not let anybody else touch their data. The other thing is that, they may have economic or historical reasons why they need to locate the systems in particular places. Once again, these are things that just don't work in a cloud environment, and as a result, we don't get them as cloud customers. What that does mean is there's kind of an interesting opportunity, and one of the things that follows from this portability model that I've been talking about is that we already have the ability to just manually recreate an Altinity.cloud cluster in Kubernetes. And I wrote a blog article late last year where I did exactly this. Basically, what I did was I launched a cluster, and then I put it up in GCP. It came up, it looked great. Everything was connected. It had 2 shards, 2 replicas. And then what I did, because I have access to the environment, I could go sneak in to Kubernetes and I could go pull the CRD. So I pulled the CRD file, its current state, and then cut and pasted just a little bit. And basically I was able to bring up exactly the same cluster in a GCP environment that I had set up myself. So a GCP Kubernetes cluster. So this is already possible to do manually. What we're actually doing is we're adapting Altinity.cloud to do it automatically. So rather than me having to go in and go find one of these CRDs, see what it looks like, and then set things up in my own independent cloud, we have adapted Altinity.cloud so that we can basically build a secure connection with any Kubernetes environment, not just our own running in our own VPCs, but with environments that range all the way to things like Minikube actually running in my closet. I haven't done this yet, but it's sort of the obvious fun demo to do. And what it does is it basically builds a bidirectional management channel. It's based on outbound HTTPS, so you don't have to. This is a common way of getting access to user environments. And what this means is now we can all of a sudden, talk to these environments and begin to put all the software in, sort of the operator, ClickHouse, other services like Zookeeper and the edge proxy I talked about. We can push that software in. Moreover, like what we do in our cloud, that software, all the software in the runtime, sort of in your that runs ClickHouse itself as well as monitors it, is open source. So this has, and we'll get to that in a second because that's really important. So what does this look like? Well, it actually looks identical to our Kubernetes clusters because there is no difference. This is an example of the sheet that you get, or the page you get when you look at one of these, one of these environments that we're managing. I can't actually tell, other than the name, I actually can't tell the difference between our Kubernetes cluster and an external one. Similarly, if we have if we want to actually manage an individual cluster, again, the page that comes up looks exactly like the page I demoed a few minutes ago. So this is a cluster. It's running a couple of nodes. We can see how much data it's used. We can see how much memory it's using. It is completely identical. So obviously there's a few things that are different. So, and we're still working through those, external network connectivity is a good example. That then, is one of the areas where we're doing a bit of tweaking, but the basic idea is that we have basically set this whole thing up and we are providing the cloud experience in somebody else's Kubernetes cluster. So this is super interesting. And let me give you a really concrete example of this. Let's say you're running, you have a big database on Snowflake. And let's say for whatever reason, you have to get off Snowflake. What you see on the left is the process that you go through to pull data out of a cloud service. This is the short version of the plan. And I'm not making this up because in my past experience, I've worked with SaaS for 20 years. And every now and then you have to get off of SaaS and it's really painful. So for example, in the case of Snowflake, I'd have to find an alternative. I'd have to go build a new database, go through all these steps, all the way through deployment, and then I might have to cycle on it a few times. These are things that take weeks or months to do. And in fact, in real applications, it's something that you would rarely do in less than 6 to 9 months. So this is really complicated. If you need to get off the service that we're building, it's really simple. You just disconnect. You own the data. The source code is, you've got the code for the runtime. It's all open source. You just disconnect and you can run it by yourself. This is a completely different level of experience because it means that migration off now becomes basically something that you can do with almost zero effort. There's also a number of other things that come out of this that, for example, let's say you were already running a data warehouse, a ClickHouse data warehouse in Kubernetes, you could go the other way. As long as it's managed by our operator, our service can dial in and basically adopt it and begin managing it. You can also do other interesting things. And as we've talked to customers, like one of the questions we got was like, look, this system that we're building, these systems that we're operating are used for trading. During business hours, we don't want you guys touching them. Can you build a gate that would prevent us, prevent any access whatsoever, from outside to this system because we don't want it touched during trading hours? That's a really interesting question. And in fact, as you begin to look at questions like that, it's clear that there's a different management model for data that Kubernetes can enable. And here's just a summary of the kind of architecture that you can now build and that we are building now. So in your management plane, you have very limited data. It's more tools, automated procedures, things like logs, so you can do quick fault diagnosis, and then telemetry for alerting. In your data plane, what you have is user data, you have your system tables, you have your monitoring. These are all things that either are just locked and cannot be seen from the outside. You can basically, build the interfaces in so that on the data plane side, customers can actually, or users can actually control that access directly. And then also things like credentials as well as your audit trail. So for example, a really interesting thing to have in these environments is if you have ClickHouse users or users for any database, you can store them in that environment. And then when you want to run a procedure to, for example, to create a new user, the management plane actually has to ask for the credential and before it can actually use it in this procedure. So this model is no longer the centralized cloud model. It has, because you're in the management plane, and as I showed on the screens, from the point of view of a user, you can still do the same kinds of things, the things that are important to developers, like being able to spin up a cluster or change it quickly, that you can do, but the data and the code are living inside the data plane. So this is a really interesting, this is a model that we've sort of had in mind for a really long time, that this is possible. We've gotten far enough along the path that we know it's possible for and will work for data warehouses. It is also possible to do this for any database. And in fact, the outline that you have for this model is that you can have a single pane of cloud, single pane of glass management, so you can see all these environments, both environments sort of that we own and environments that users own. You have on-demand DBA support, so you have the ability to drill into the environments, even the user-owned ones, and quickly solve problems. But users have the choice to own data. They have the choice to own the environment. And then I think this is another really important thing, is that it also enables, many businesses are very focused on open source because they don't want lock-in. So it does give you this ability to have this fully open source runtime that if you need to move, you have the data already, but you also have code that you can run yourself. So all of these issues of migration back and forth just become much, much more tractable and much easier for businesses to handle. So this is what we're doing. What I've talked about is our experience and how it applies to this. But I think that this is a model that can apply to not just to data warehouses, but to data in general. And so this decentralized management for data, I believe, gives us the opportunity for people who want it to combine the best of the cloud experience, where you have the automated procedures and everything, and sort of very high levels of support. At the same time, you have the ownership that many users need, to run their businesses. So we haven't officially announced this, but watch this space. I think we're going to be bringing this out. If you have interests in this, either what we're doing or you're doing something similar yourself, we would love to talk to you. So I'm available on the DoK Slack workspace. You can just message me there directly, or you can send email to me. And beyond that, we have sort of the products I talked about: Altinity Cloud, the Kubernetes operator for ClickHouse. Feel free to check these out. The Kubernetes operator, for example, is Apache 2.0. It's used by thousands of installations. Tencent, for example, we're honored to have them running their cloud on it, which is pretty cool. They send us PRs for every now and then. And then finally, we're hiring. So if this topic is interesting to you, and you like this talk, you like what we're doing, check us out. We're always looking for talented people. So that's it, Bart. If I can hand this back to you.
Okay. Yeah, that was, anyway, loved it from start to finish, as usual. Very, very well put together, based on empathy, practical, good to follow it. Questions here. You did talk about, the evolution of servers over time, and it's by coincidence, we actually have a talk tomorrow on the DoK Students Day from a young man who's 15 years old, living in the East Coast in the US, who's going to be talking about serverless databases. Any comment on that?
Yeah. So, my first comment is, what does he mean by serverless databases? So
you'll have to come tomorrow to check it out.
Yeah, I'm going to have to.
I'll tell you.
Yeah. So, So there's two kinds of serverless. There's sort of like, there's two definitions there. In the database field, what I find people most commonly mean by this is you don't have to know what servers you're actually running. And this is actually a big advantage of cloud systems. This is something that things like Snowflake, for example, don't, you sort of have a notion, an abstract notion of compute. You have virtual data warehouses, and so you know that there's something out there that's probably a VM or collection of VMs, but you don't have to worry about how it arrived and how it and how it exists. This is something you can actually do in Kubernetes. So it's really a matter of, does your database understand things like, how do I decouple compute and storage? If your database understands that, then this serverless experience is something that you can create in Kubernetes. It happens that we don't really do that because ClickHouse in its current form really does require some knowledge of like, where's the data located? And, can I get to specific nodes to go look at it? And I'll give you a simple example. If you need to join very large data sets, this is difficult to do in ClickHouse right now. You really have to know exactly where the data are located. So this does come up. I think in general, this first definition of serverless, this is something that Kubernetes will enable, and I think we'll increasingly see going forward.
Okay. All right, good to know that. I guess the other thing here is that in terms of where we're at, and we talk about this a lot, and you mentioned it too, that data considerations on Kubernetes in terms of stateful workloads, of sort of, watershed moment, the arrival of stateful sets, but that was actually, I don't know exactly how many years ago, but if I'm not mistaken, 3 to 4 years ago, and perhaps longer.
It's more even.
That's what I'm saying. It's more. So in that sense, there is relative maturity around that. You also talked about CRDs. Is there in the next? I know it's difficult to pinpoint an exact time, but what are things that you expect to be happening in terms of this stuff not becoming so much like a Wild West and more just becoming like everyday sort of stuff where it's like, hey, yeah, we know the standardized practice is how we're doing things.
Yep. I think the biggest game changer in this whole thing has been the emergence of operators and the ability to define custom resources. They still have issues, and I'll give you an example of one that's actually been kind of painful for us. Is that when you define when you create a custom resource definition, it's global to the entire Kubernetes cluster. What that means is if we come in and we want to adopt something, it's actually pretty easy to adopt ClickHouse because presumably if you're asking us in, you want us to take over. But what about all those other services? What about Grafana? What about Prometheus? Let's say they have operators as well. What about Zookeeper? Well, if you're already running one and you're particularly attached to it, if we come in and sort of install that operator, it's going to create a CRD, and it's a good chance it's going to wreck whatever you have there. So that aside, operators have been brilliant. They have helped enormously. I think the biggest thing that I'm looking for in Kubernetes is to be able to manage local storage better. And right now what we do is, in order to allow us to resize VMs, we use block storage. And that's okay, but it's kind of expensive and it's lower performance than NVMe SSD. What we would really love is, and what you really need to enable this to work at scale, is if you want to resize something, you need the ability to move storage efficiently between locations. And this is a really key capability that doesn't quite exist inside Kubernetes yet. I know that people like Pure Storage are working on this. In fact, if there's storage people listening, we would love to talk to you about this. We've got
storage people in the community, so I think that's something that would be interesting to pose and see what their response is to that.
Yeah, what I think is important though is to have this, because the last time I was looking at CSI and sort of the out of tree storage management, this capability of like resizing a local disk, I don't see it in the abstractions. Maybe I'm missing it, but we as a team, we feel like this is something where we're probably going to have to write some more application logic to make this happen. Yeah. And because Kubernetes doesn't supply it yet. It's an example of where we'll build a service to do this in Kubernetes, and that's how we'll solve this problem. But it would be great if Kubernetes had the abstraction to begin with.
Good. Well, I like that as something to hang on to. I mean, we are going to have a talk specifically about CSI in DoK Day and KubeCon from someone who's quite experienced in that area. And we have other talks as well about storage. That's good. And, you know, I may have asked you this before, so I apologize if I'm repeating, but one of our community members, shout out to Alvaro, who's very passionate about Postgres. He's frequently said that CRDs are his favorite feature in Kubernetes. Would you agree, or would you have a new
Yes,
one?
absolutely, hands down. It makes it possible to manage distributed applications, and I think that's if you distributed applications with data. You know, stateful sets work great for really simple applications, like, you know, hey, you got a farm of web servers, but they are inadequate to solve, you know, to build a big system. I'll give you an example. You know, with stateful sets, there's no real guarantee what availability zones your nodes are going to land on. It just isn't. And if you go look at the Kubernetes docs, it's just mush. I mean, there's no, you know, you cannot. In fact, I cannot extract from the docs what the semantics of placement are, because I think they probably are somewhat random. So that's an example of where you actually need an operator which can, you know, have a CRD which can understand the difference between, to say, hey, you know, these replicas need to go in this availability zone, and if you got two other availability zones, sprinkle the rest of them across it and make sure they really arrive there. CRDs do this because you can then write the logic to make sure to, you know, to tweak your pods and annotate them correctly so that these things happen. I love operators. Operators and CRDs, they're brilliant. It's really been I think one of the biggest innovations in Kubernetes in the whole history of the project.
All right. Good. All right. Well, strong answer there. No doubt. You had no doubt whatsoever. So I'm sure Alvaro would be happy. And I'm curious to see what other people have to say too. We did a panel actually that we recorded recently that we'll be putting on the next couple of weeks, just focusing on the operator paradigm. And I think it's something that we're hopefully going to expand, and we would definitely like to have you on to hear your thoughts.
I would love this. And if there are people in the, you know, if this talk has interested you in any way, we want to collaborate with people to make this model work. Because this swing to the cloud and this swing to this complete centralization, it is not just what we're hearing on the ground level by talking to people who are really building these systems. One of the things that just comes out is how varied their reasons are for placing things in different locations. We're doing the centralized model right now because it's really convenient for vendors. But if you look at what users want, they actually want this level of control, or more accurately, they want choice. They want the ability to choose whether to own their data, whether to own their infrastructure. And I think this is something that Kubernetes has a real shot at enabling in a way that just wasn't. Going back to that argument in the restaurant at the beginning of the talk, it was not obvious that Kubernetes was going to make this happen, but it clearly has.
Very good and well said. And I think it also was reflected in the survey results that you showed about how users are responding with, like you said, their concerns, their interest in control, the things about data security, privacy, things like that are being factored in there too. These are good things. And, you know, vendors can sometimes suffer from maybe being a bit of an echo chamber or not having, you know, enough contact with end users, which can sometimes be tricky too. But it's something that I think everyone needs to keep in mind, and I'm glad you put it out there. We do need to wrap up, but before doing so, as usual, we have our wonderful artist, Angel, in the background doing a artistic representation, a graphic recording of what was being discussed. So he really liked the idea of portability and made you as a very cool astronaut. Well, I guess an astronaut, it doesn't have to be you. But this was good. This was good. And he also had very positive comments to say about how easy it was to understand all the stuff you're explaining. So good examples of getting the Miller example in there and also the restaurant argument. Very good. Very, very nice presentation. As always, Robert, we look forward to your talk in DoK Day on the 16th. And you heard it here first, folks, but we will be doing something in the Bay Area in July. We got to pick a place and a date. And maybe we can explore this operator paradigm at that point, or
that would be
topic.
Totally cool talk. And if there's storage people in the Bay Area, I'm located in the Bay Area myself. Yeah, love to talk about this stuff. I think the there's just some really, really great things that are opening up for Kubernetes, and it keeps getting better. The more stable this is, the more things we can build on top of it. So yeah, looking forward to that.
Likewise. Robert, thanks so much. Absolute pleasure having you today.